Hi, let's learn or practice how to do neutralization problems. Okay, neutralization is when an acid and a base react, strong acid, strong base, and they cancel each other out. They make water and a salt, and you're going to be doing some double replacement reactions on this one, so you might want to remember that. You've got AB plus CD makes AD and CB. And for all of these, you will use that. Remember, you should crisscross when you put things together. Here we go. It says, what is the molarity of sodium hydroxide? If it takes 40 milliliters of sodium hydroxide to reach the equivalence point is just like the exact moment when the acid and the base cancel each other out. So calm down, Allie. Calm down, Jaden. Chill, Thomas. It's just equivalence point. It's just a word that means when the acid equals the base. And then it also says titration. Titration is just a controlled neutralization. So you can kind of just ignore those words. That's the process by which we do this. Anywho, after everyone has chilled, 50 milliliters of 2 molar HCl. Okay, so this is the acid. This is the base. I know that because this has an H in it. That has an OH in it. So when you're neutralizing them, you're going to need a balanced reaction. Actually, there's probably 20 of you who could see that you really don't if you just kind of do the math backwards, but whatever. We'll write it out. Sodium hydroxide plus HCl. Everything is +1 and -1 here. So you're going to get sodium chloride. That's A and D. Outsides go together. And HOH insides go together. That's just water, and they all balance out. So you're set. It's all 1 to 1 to 1. So when you're using the equation, which I probably should have wrote down also, NBMAVA equals NAMBVB. When you're doing that, since this is 1 to 1, the NA and the NB come from the balance reaction. So you won't need those variables for this particular one. And as long as everything matches up in terms of milliliters, you don't need to convert to liters if you don't want to. So now I've done all these, said all these words for a very simple problem. Our number of moles of base is 40. It doesn't really matter which side you put it on as long as you keep it together. But since I set it up that way, I'll put them on this side. It's 40 milliliters of base. I'm looking for the molarity of the base. The volume of the acid is 50 milliliters. And the volume of the, volume of the acid, the molarity of the acid is 0.2 molar. Once you set it up that way, you can solve very simply. Divide both sides by 40. You just take 50 times 0.2 divided by 40, and you end up with 0.25. So that's the molarity of the base. MB equals 0.25, and the label, of course, is M for molar. 50 milliliters of 0.3 molar KOH are required to titrate 60 milliliters of H2SO4. What's the molarity of the H2SO4? This one's going to require a balanced reaction as well. H2SO4, I think this one was on the note guide, so you can probably copy it over real quick. KOH, you get outsides go together, insides go together, K2SO4, and also HOH. And so now, I should balance it. This is where the 2 comes in. You're going to need a 2 right there to balance, and a 2 right there to balance. When you're balancing the waters, this OH is that OH, and this H is that H. Makes your life a little bit easier. That's why we write it as HOH. Anyway, 50 milliliters of 0.3 molar KOH, 50 milliliters, 0.3 molar KOH, that's the base. So then on this side would go the number of moles of acid, which is a 1 from the balance reaction. So Na is a 1. And then instead of equal to the acid numbers are 60 milliliters of H2SO4. I'm looking for molarity of the acid, and the M, or the number of moles from the balance reaction at 2 right there would be the number of moles of base. I just flipped this around, but it still works just fine. Anyway, take 50 times 0.3 divide by 60 and divide by 2, and you end up with 0.125. Oh, wait, the answer is right there. That's so funny. So MA equals 0.125 molar for that one. Next one, 60 milliliters of 1.2 molar NaOH required to titrate 40 milliliters of HF, what's the molarity of the HF? If you're catching on here, you can see this one as 1 to 1 because there's no 2's here. That makes your life a little bit easier. You don't have to write this out, but you can. Sodium and fluorine go together. Sodium is +1, fluorine's -1. Hydrogen and hydroxide go together. There's your water, +1 and -1. So this is all 1 to 1, so I don't need to use the variables N, B, and A. So to solve this problem, I just put the numbers in. I've got, might as well do it the way that I wrote it here. Acids first, so 40 milliliters, I'm solving for the molarity of the acid. And the other one is 60 milliliters and 1.2 molar for the base. Again, I know it's a base because it has an OH in it. So take 60 times 1.2 and divide by 40. 60 times 1.2 divide by 40, and you end up with 1.8. 1.8 molar is equal to the molarity of the acid. Whoops, that's not how you draw a square. Next one. 0.4 molar NaOH, what volume this time to titrate 100 milliliters of 0.25 HCl. So HCl plus NaOH for your balance reaction. H and OH go together. It's just the water. Sodium and chlorine go together. Sodium is +1, chlorine's -1, so they just cancel out and you get that. So it's all balanced. It's all 1 to 1 to 1. That means you're not going to be using NB or Na. So in this one, I've got 100 milliliters of the acid. The volume, or molarity is 0.25 molar of the acid. The base is 0.4 molar, and I'm solving for the volume of the base. So divide both sides by 0.4, and you will find the volume of the base equals 62.5 milliliters. It's in milliliters because this one's in milliliters. If this was in liters, then this answer would be in liters. Okay, finally, in number 5, we've got 40 milliliters of 0.1 molar H3PO4. That's going to be a change because there's a 3 there. To titrate 150 milliliters of NaOH. When you crisscross these now it's going to be a little bit different. So I've got H and OH. It's always going to make water. Remember, the product of any acid-base reaction is always going to be water. And then sodium and phosphate. Sodium is +1, phosphate's -3. So when you crisscross them, you're going to get Na3PO4. And then to balance it, you're going to put a 3 in front of there. So you have 3 OHs, and then you put a 3 over here, 3 H's. That means the number of moles of base for the reaction for this equation is going to be a 3. Okay, so then to solve it, the setup is number of moles of base, so 3 from the balanced reaction. The molarity of the acid is 0.1 molar. The volume of the acid is 40 milliliters. Set it equal to the base side, the number of moles of acid. Well, there's just nothing there, right? So 1. So, I mean, you can write it if you want to. And then volume of base is 150 milliliters, and the molarity of the base is what we're looking for. So take this equation, divide both sides by 150, and you will find out that the molarity of the base is 0.08 molar. So there's a quick setup for how to use the neutralization reaction, a little review of how to write double replacement reactions. Don't worry, you're not writing them for all the problems for the rest of the year. I just wanted to use it for this one. But a good use of neutralization reaction or equation, which is what happens when an acid reacts with a base. This has been really fun. Always a pleasure to see you guys. Okay, bye.